So we are the team that's been working with Rockwell Collins. The Rockwell Collins sponsors, Michael and Casey, and then we are the team. I'm Lance Willett.
I'm Jordan Getz.
I'm Mitch Kalaji.
Clay Moody.
So what we'll briefly be going over is kind of an overview of what Rockwell is, the product that they've asked us to design for them, the proposed solution that they gave us, the schedule that we've followed, what our progress has been, and the status of the project currently going forward. We'll be going over some of the issues and risks that we faced, and then we'll go over some of the story points, how that played into the way the project went. A quick reflection over the project, and then what the next steps are. Then there'll be a question and answer section.
So Rockwell Collins is mainly an aircraft industry. They deal with commercial, business, and military aviation, and they also do work with airports. So the system that we mainly designed this for is for their FOMAX unit. It's an information management system being developed by Rockwell Collins. And right now the system is being field tested, and so is our application actually. And it'll help in debugging those potential units by potentially finding the bugs and such. Our application is useful because it helps save on time and personnel resources that would otherwise be spent transferring the data and sifting through it. Whereas our application helps allow those non-technical staff to be able to transfer those files using FTP, untarring those files, parsing them, displaying the data in a user-friendly way. And it also has a nice graphic for displaying the data and more easily spotting the errors in code. The proposed solution that we were given off the bat looked like this. As you can see, the teal area is kind of the file tree, orange area is the filter input, green area is the results table, and the pink area is aggregated filter results for the graphing. And our midterm solution, this is a screenshot of it. We had the basic FTP file transfer. The file tree had some basic usability to it. The parser was operating pretty well, but it still was slow at times. And then displaying the filtered and parsed results in a tabular format. So we had to scroll through the graph. And then we also produced a Windows executable build that was easily run. And this is our schedule. It has some of the user stories that we did throughout this time. The green ones are ones that we all got done. The red ones are ones that we didn't quite get to. They were kind of the extras at the end. Some big ones are file tree quality of life improvements, results paging, and then a lot of updates to the graphing, making it a lot more user-friendly.
This is an overall. This is a picture of our overall application of where it is now. The file tree on the left, you can see some files are highlighted. You're able to open directories and close them again. We'll go over that more later. This is the filter results panel. It lists off the filtered results and their attributes in a box at the bottom of the screen. And then there is the graphing portion. It's on the top right of the application. It shows off basic functionality of that, and we'll go over it more in detail.
All right, so this is an example of the JSON configuration file. So each of these properties allows you to configure the application. So for example, a default path sets the default download directory when you FTP a file from a remote location to your local computer. The delimiter allows you to set the delimiter in each of the log files when we parse them. The fields allow you to set the name of a field and then the data type of a field in the log. So we can try to parse a datetime object as a date and time as a datetime object in Python. We can try to parse integers as integers so that later when we do our filtering, we can do filters that are intelligent to those sorts of data types. So like dates within a range or integers greater than a certain value. And then the sorting field sets like the default sorting. So when we sort all of the results after performing the filter, it sorts them by whatever the name of whatever field is configured here. So we could just as easily set this to log level, and then all of the results would be sorted alphabetically by log level. And then a couple other properties. So here we have a demo of the file tree functionality. So in this demo, what we'll show you is we have no files loaded in the file tree. So we will go and we will open a local tarball file, and this will untar the files and extract them into the file tree. And now we can see that the file tree has been updated to include all those files that have been untarred. We can select individual files, or we can select a range. So selection is with right mouse. Selecting a range is you hold shift and you right click, and then you right click again, and it selects all files in between the two files that were selected. And then we can click apply filter to show all the data. Otherwise, if we double click a single file, it deselects everything except that one file and applies whatever filters entered into the bar in that. You have a question?
Hey, can you just kind of clarify a little bit more of the context and who's using this application and where this is deployed? I'm having trouble following that.
Yeah, so Rockwell Collins sends this product to potentially some of their customers who are working on using some of the new units that they're producing. And so in order to detect if there's been an issue with a unit, they get a whole tarball full of log files. And so this product basically allows them to parse through those log files, view the logs themselves in a tabular format versus reading through lines and lines of logs that are separated only by like an ampersand or a hashtag. So it gives a nice tabular format. And then also we can, as we'll show in a moment, we can use the graph to aggregate the number of results in a certain time span. So we can see if there's like been a large influx of events with a certain error code, for example.
Okay, thank you.
So what we showed you here was basically the control shift click, and then control clicking also selects an individual file. Control A and Control N, which were at the very end of that one. If you do Control A, it'll select every file in the current directory. If you do Control N, it'll unselect all files. So those were some of the quality of life updates that Mitch had mentioned before for the file tree. Here we have a demo of the basic FTP file transfer. So we'll get this one started. So for this one, what we will do is we will go up to the upper left corner of the application. We will select File, and then there will be an Open Remote option. Here we paste in a FTP test site. The site provides just some demo zip files that you can download. And then it has dialog boxes for connecting to the server, and then it shows the progress as it downloads each file and attempts to extract it. Because of the fact that this site is just for testing if a FTP connection is working, all of the zip files are empty, so when we extract them, there's actually no files in them, so it doesn't produce anything. But at the end of the extraction phase, or download and extraction phase, we'll see that the file tree is updated with the files that have been downloaded into the download directory. And in an ideal situation, there would be content in those zip files, and that would then also be displayed in the File Explorer. So we'll skip this along a little bit. And you can see up there that all of the files have now been populated into the file tree. And so this would be useful for, instead of having to manually email log files, you can just make them available over an FTP server, and someone who's using the application could then download them with the application and have them automatically extracted. We have a demo with the parser, filter, and filter results. So in this case, you can write a Python expression with some syntactic sugar, which allows you to perform several different kinds of date filters and value filters, which then parse through each of the lines in these logs that we've selected, and then display the results below in the results section. So here we apply a filter, and it's parsing through all the files. and then when it completes, it populates the lower section with all of the log lines that match the given filter. So in this case, we have a date filter, so basically anything that has been created beyond a certain date is shown by this filter. In this case, we also clear the filter to show pagination, so you can, it shows about 5,000 results per page, and then we can paginate through each of the, I think this total query at the bottom, it looks like it has several thousand results, so we can paginate through each of those. Then we can do different sorts of filters. So this is like a string in another filter, and then we can save the filter, give it a name, which we're doing with this pop-up box. So basically, if worn is in the log level message field, and then we can close the application, reopen it, and in this drop-down box on the lower right, we can actually load that saved filter. So this will allow, and this saves it to a filters.dat file, which then can be distributed with the application to provide some basic filters for the people who are using the application. We can also change the name and edit the filters as well as delete them, which you'll see here. So here we're checking to see if error is in the log level instead of worn. And then in this case, we'll now delete the filter by clicking the delete button. And it's now gone. And this final one is a cool feature where you can right-click on any of the results in the filter results and then click Show Surrounding, and it will let you basically create a date filter from that log message to some time interval before or after and show all log messages surrounding. So this is, say, you have a critical error, you want to see what was happening so much time before and so much time after to help with troubleshooting.
And yeah, then here we'll be showing a video of how the graphing functions work. First, you'll see that we have a file selected already, and we will filter is applied, and we'll add them to the graph, plotting each of the points out. This is a 10-minute aggregation, I believe, for each of the results. And then we will apply a new filter with different selected files. Add those to the graph. You can see it's a different plot. That way you can compare them. This is the zooming function, and able to pan around on the graph just to get a better view of different data plots. This is the changing of the aggregate of the graph. When we click OK, it'll reapply the last filtered results, and then it will also reset the graph so it zooms in on them. And then here we'll be showing that if you click on a plot on the graph, it will apply a new filter into the bottom of the filtered results of the points that were specifically in that aggregate of the graph.
Yeah, so basically how aggregation works is starting at the first date in the log, every certain aggregation time period. So in the first plot that was showed, it was 10 minutes. So every 10 minutes, we aggregate all of the number of occurrences of that, of whatever's filtered into one point and count basically the number of occurrences. And then so you can configure that. So the second one, it changed it so it was showing it aggregation of every 5 seconds, which is why it looked like very blurry because there are so many points. And then the last one was every hour. So you can see what events happened in that hour and how many events happened in that hour.
So some of the issues and risks that we faced when carrying out the project, initially the big issue was how are you going to parse, filter, and display up to 60 gigabytes of data? It's a big issue. Essentially what we did was we kind of broke it down using the way the files are parsed and filtered, so you don't have all 60 gigabytes in memory at any given time. And then later on, the issues were mostly revolving field testing. As the application became more useful, new use cases came up, different issues that weren't in the product before it became apparent. And we had unforeseen data irregularities where the test data we were using wasn't fully inclusive of all the different types of data we would be getting from actual log files.
A good example of that too is if you just go into the file directory and you do Control A, it'll select a couple of files like a DHCP config that outputs logs in a different format than all of the other logs. So there's some irregularities with trying to parse that. If there are not the same number of columns, it can't parse it the same way it would all the other files.
And then we also faced issues with testing, filtering syntax.
So that's just like irregularities with like what happens if we add several date filters and too many parentheses sometimes, because we had to write a lot of the expression evaluation is done by the Python eval function, but then also a lot of it is done by manually parsing some of the queries and removing and breaking up unneeded like clauses.
For the sprint analysis, for our third story, you'll see that we estimated 27 user story points, and we completed 50, and that's just showing how many ended up getting added after we initially estimated what we were going to be working on and what we ended up doing. Actually, same goes for sprint 4, where we started with the 27 and ended up with 34.
So looking back, there are some things that we would have done differently. Big one is split up tasks more evenly between different group members. We would have found a better hosting solution for our source control. What we ended up using was a GitLab set up on a Raspberry Pi in Jordan's apartment, which was not always reliable. We had to find some workarounds for that because it kept crashing. Time management obviously could have been done better. And then keeping up with the documentation. Anytime you add something to the project, be sure to add it to the documentation concurrently. Things that went well, as you could see on one of the earlier slides, we implemented almost all the features that we intended to implement, all except 2. And this was done partially because we chose well-documented libraries, WXPython, Matplotlib, very well documented, easy to extend, and we handled the addition of new story points as they came up efficiently, and we're able to kind of roll with the punches on those. So the next steps for us are to hand off the application fully to Casey's team. They'll be testing it. They have the latest build now and are using it, and they have already come up with some bugs that we didn't see coming that we've last minute been able to fix. And we have provided them with the source code and instructions on how to build, so they are able to extend it from here.
Any questions?
I guess other than the few things you kind of mentioned that had been identified that hadn't been implemented, were there any other big features, or is this something that's mostly feature complete, get the bugs fixed, and it's kind of just needs periodic maintenance, or is there even a next phase beyond this?
A lot of the use cases that were come up with were basically ones that we would have a meeting. There was actually one week where Mike was gone, and Casey just had a whole bunch of ideas that he requested of us. And then it was kind of, as we go along, he would come up with new things that'd be, hey, this would be useful if it were to do this as well. So there isn't, he's missed a couple of meetings because he's been traveling due to working on this product that this application is supposed to help with. And so we haven't had direct meetings with him in a while. However, from the sounds of it, he's been testing it, and he's optimistic that any additions they should be able to figure out and add themselves. And that right now, just getting it basically stable is more of a priority than adding new features.
This is going to be sent out to users?
I believe it was supposed to be to basically Casey's internal team, as well as partners that they work directly with for debugging some of these units.
So given that it's going out to partners and people, is there a need or did you build a user manual?
Yes.
Yes.
Yep.
One of the things that Casey especially stressed early on and throughout the entire process was this will be used by a lot of non-engineer type people, is the terminology he used. So it had to be straightforward, and if you plop someone down in front of it, they have to be able to go from no knowledge of anything about how it works to being able to use it to troubleshoot, complicated problems with aircraft.
Yep.
That was
So he had us write some ASCII doc documentation that then Casey said he has a script that builds it all into a nice PDF that they can distribute with the application.
Yes, it's not something that capstone teams usually do, but had there kind of been any usability studies where at some point, or maybe even just now, hey, let's hand this over to one of these non-technical people and see how long does it take before they can do something, or they maybe already know what the problem is, but how long does it take them to use the tool to arrive at that?
I don't know if we've been made aware of that, but I know that Casey has been testing it the last couple days with some people on his team and sent like 5 bugs that he found yesterday that we got fixed. So, any other questions? All right. Well,
Thank you.
thank you.